Morning students, already we have started chapter 22, which is surface area, volume and capacity. So in this chapter we'll cover like cuboid, cube and cylinder. So the introduction of this chapter is like we have to know what is the volume, capacity, surface area. Volume is space occupied by body, like a solid is called, it's a volume. The capacity of a container is, it's a internal volume, that is called capacity. And a surface area, the sum of area of all faces of a body is called, it's a surface area. So we will understand about these things. So we will discuss regarding this. So like here is the some unit, like that is the unit of length, this is the unit of volume, this is the units of surface area. So like meter, so whenever it is the volume, so as we know that volume is a like a length, breadth and height, we are multiplying the 3 units, so that is the cube, that is the meter cube. And whenever the area, we are multiplying the only 2 units, right? So that's why it is a square, and this volume will always in the terms of cube. So like centimeter, millimeter, likewise the units that we will use, according to that we will have to write it. So only we have to take care, when the volume is there it is always cubic, and whenever the surface area it's a square, because in a square 2 units and a volume 3 units. So like meter cube means that is the meter into meter as well as into meter, so 3 times, so that is a 100 into 100 into 100, and we have converted into centimeter, because in a 1 meter how many centimeter, 100, so that is 100 into 100 into 100. So likewise that is a for the centimeter also in the same way. But the thing that we have to keep in the mind, which is the volume of liquid or gas, which we generally measure in liters. So for that there is a meter and liters, there is a relationship between the meter and the liter, which is a 1 meter cube is equals to 1000 liter, and 1 liter is equals to 1000 centimeter cube. So that you have to learn it, you have to keep in the mind, 1 meter cube which is equals to 1000 liter, and 1 liter is equals to 1000 centimeter cube. So now we will see the further of this chapter, which is the cuboid. Cuboid is a rectangular solid, it is made of rectangular faces. So a cuboid is a solid bounded by 6 rectangular faces. So many faces? There are total 6 faces are there, right? So there are total 6 faces in this. And so what is its volume? Volume is length, breadth and height. We multiply the 3 units L, B and H. And the volume of cuboid, that we if we further derive, or like we can arrange it, so L into B, that is the area, and this is the height, right? So L into B, so for that we can write the area of the base and height. So the volume of cuboid we can get by the 2 methods, which is the L and L multiplied B multiplied by H, or the area of the base, the area of the any base we can get, and is the height. If you multiply, that will also give you the volume of the cuboid. Next, the total surface area. So total surface area means it is made of, this a cuboid is like this. So there are how many faces are there? 6. So suppose the first face, this one. So if you get the area of this face, right? So what is there? This is your length, this is your breadth. So L into B, right? So that is the, so such kind of this L into B, there are this 2 sides you can see, upside and down. So there are 2. Similarly we can get for this also, let me, this is the H, so H into B, so this is again 2, right? So 2 to 4, and one more this other side we have also, this side. So total we if we get the combination of all this, so 2 times L into B, 2 times B into H, and 2 times H into L, right? Total 6 faces are there, all 6 are covered. So combinedly when we add these all values, so that's the your total surface area of cuboid, that's the 2 L into B plus B into H plus H into L, which will give you the total surface area. Total surface area means the area of the all the 6 faces, right? So that is the surface area of the cuboid. So next, the lateral surface of a cuboid, which is the room. So area of 4 side wall, that is the 2 into L plus B into H, that is the lateral surface area of a cuboid, which is also called room. Then after we have the length of diagonals of a cuboid. So its a formula is root over L square plus B square plus H square. So these are the formulas that you have to by heart, you have to write in the copy. So that is the lateral surface area of a cuboid, which is the room area of 4 side wall, because in a room there are total how many sides are there? 4 side walls. So that is a 4 side wall areas, 2 into L plus B into H, right? So that is the lateral surface area. Then after we have the cube. So cube is a rectangular solid whose each face is square, right? So earlier cuboid was made of the rectangle faces, and here it is made of the which kind of face? Squares, right? Square. Okay. So now it's a volume same. We will give the L into B into H. So here all the sides are same. So everywhere is the A, or that sides denoted by S or A. So which is your A cube, right? And it is also called H cube. Then after we have its a total surface area. So we will have the again 6 faces, and each is a square. Its area is A into A. So likewise total its a surface area is 6A square. Similarly, its a lateral surface area 4 into H square. H means the side, 4 into side square. Then after we have the diagonal, which is the H into root over 3. So all these formula of the cube and cuboid you have to by heart, you have to write it, because we will use in the solving the questions. So now we have some examples like to find out the dimension. Okay, so like the length and breadth and of a cuboid is given 6:5:4. So we have to assume it. Let length is 6x, breadth is 5, okay, height is 4x. So according to that we will find the value of x and we will put the value and we will get the answer. So we can get the surface area of the cuboid, right? So like here total surface area is given. So total surface area, which kind of shape? This is cube. So its a formula is 6 into side square. So we'll put the value and we'll get the answer. Already it's a solution I have forwarded you. Okay, so I hope you have done this exercise 22A. This is all based on this only. These are all the formulas, and its solution already I have forwarded. So now today we will see the further of this chapter, means the next exercise, which is your applications based on this cube and cuboid. So as you can see, this is the applications where we use this cube and cuboids application. So now for a room, if it is a room, every room has how many walls? 4 walls. 2 walls along its length and 2 walls along with width, right? There is a 4 walls. We have the 4 walls. So one will included with the length and one will included with the width. So area of each wall, one side is L into H and B into H. In the both height will be covered, but one is along with the length, one will cover along with the its width, right? So further, as you can see, area of 4 walls of a room. So what is the formula? 2 into L plus B into H, and which is nothing but lateral surface area. Just now we have seen the lateral surface area of cuboid, right? So what was that? Lateral surface area of your cuboid, which is your area of 4 walls, right? That is a 2 into L plus B into H. The same formula is here. But here you have to keep in the mind the area this area included the door and window. Suppose your home is there, so in this what is called window and the doors are also there. So this is also included, is not excluded. So suppose if it is in a question, if it is given that there is a dimension of the window and door, so the area of these windows and doors you have to find out, and you have to subtract here, because it is included in this, because it is assumed that in a room there is no wall, no door and windows. Okay, so this then the area of roof in this it is excluded. So area of roof is also the area of floor L into B. So if it is a 4 wall only, then lateral surface area. But in the room, as you can see your room, there are 4 walls are there around you. So for that 2 into L plus B into H. Okay, so this is the 4 walls. Okay, so this for these four walls you have the formula 2 into L plus B into H, but there is a top also as well as the bottom. Okay, that is the roof and the floor. So for that L into B. So according to the questions you have to arrange it. Next, according to based on this we have some examples of this question, examples based on this concept to find out the is a lateral area, what are the cost for that. So now one more concept that we have to see, which is the for a box. We have seen for the room, now we have for the box. So for a box, what is the concept behind this? So space occupied by it. So any box if it occupies some space, okay. So for that what is that? It's a external volume, and it's a capacity, it's a internal volume, and for the material external minus internal. To understand it, just you go through this, just I try to give this figure, just let it be. It's made of some material and it has some width, okay. Just try to get some idea regarding this. Let it be, this is the one of the figure of like a cube or cuboid, whatever. So as you can see, if we'll suppose that it's a total length from here to here, it is a 5, okay, from this point to this point, this is the outside. But if we'll go inside this particular one, and inside it is a 4, right? So where is the one is short? One is short because of the it's the width of the material, right? So whenever it is external means we'll take the this point edge to edge, means outside edge to edge. Internal, when we'll take the internal means the inside one. So the width of the material is excluded, right? That is the, if it is the internal, this is your external. So that difference the width of or the size of the material which is used. So here it is given. So space occupied by it, it's external volume, you have to take outside. It's the capacity internal, and the metal for the volume of material, if you can you can subtract external volume minus internal volume. And for the closed box, it was the open box. Now closed box, if it is a closed box, so for that, if its external length is and breadth is L and B and H, and its the walls are unit, that is the its the thickness is given. Its the walls thickness as I have given here. It's a thickness, let it be, this thickness was as here, the difference is was 1, so this thickness was assumed as x. So here you can get it for this internal length external minus twice is the thickness. Why it's twice? Because both side it will be added, this side as well as and this side, right? This thickness as well as here thickness, so it is a x and this side also x, so combined it is a 2 times. So that's why it is here mentioned it is 2 times, which is your twice the thickness of the wall. So what is its internal length? L minus 2x, and for the internal breadth, which is your B minus 2x, and for the height, because 2 times it was subtracted. So for this for the closed box, these are the formulas. So as you can go through it, external volume, internal, that's for the box, this is for a closed box, okay. So based on this this B exercise 22b is there. So it's a solution I will give you in the next class, and whatever the PDF I have given, the solution PDF, its solution is given, just try it. Some more dots if you have, we will cover in the next class. In this exercise the questions are there, your dots will cover in the next class. Go, first of all, it is advised that you are advised for that, first of all solve all the examples of this chapter actually, then go for the exercise. So after this we have to see the next point, which is your next topic, which is your cylinder. So for the cylinder, a solid, a pipe shaped figure which has a uniform circular cross section, that is called cylinder. So this is the shape of cylinder. As you can see, there is 2 circles and 1 rectangle. 1 rectangle, 2 circles, when we combine, so we will get a cylinder. So for this we have the area pi r square, this is the area of the cross sectional area, perimeter 2 pi r, that's the same formula as for the circle we are using. So curved surface area means about this, they are the curve, so perimeter of cross sectional into height 2 pi r h, and total surface area, curved surface area plus 2 into area of cross section 2 pi r h plus 2 pi r square. So here the four formulas for this cylinder, so that you have to write down your copy and by heart this formula. So and the extension, and it's the volume, that is the pi r square into h, which is your pi r square h. So the, as you know that the value of pi, which is 22/7 or 3.14. So these are the formulas. So for this for this chapter, like we have a cuboid, cube, cylinder. So first of all you have to write all the formulas, write down, learn it, the formulas, and based on this you have to solve the exercise 23b. So as I have told you, first of all you have to refer, you have to go through the all the examples of this exercise in this chapter, whatever the examples, solved example, go through that, then you can do the questions of this chapter. Like this is the exercise 22c, and your doubts and some more questions will cover in the next class. So first of all, just solve all the questions, write these questions, and the solutions already I have given to you. So I hope you can do this, and first of all try to get its theory, what is the application, formulas and all. Okay, thank you.